Hello, it's Chastity here, and I have a computer programming rant to do today while I walk to Walmart. So here's the thing. I have my desktop computer, which is a Minisforum mini PC. It has Linux, Debian Linux version 12, and it's my main computer, but then I have my Windows 11 laptop. And I've been thinking about what to do with it, okay? Because I have been keeping Windows around on that machine mostly just because I have this idea, well, maybe I'll make some kind of great game that I can sell. And so if I have Windows, I can publish it on Steam for Windows and make some money that way. So that's really the only reason I've been keeping it around. But I've also just toyed around with the idea of scrapping Windows on it entirely and installing Debian or maybe Kali Linux or something like that. So what I decided to do, though, is while I still have Windows on that machine, I thought, what if I start on an assembly arithmetic algorithms book for Windows? And I was thinking about it, and I was thinking, well, there's different approaches I could take. I could do 32-bit Windows, which I already know pretty well, and translate every single program from the Linux book into Windows API calls for the Windows assembly book. I thought about doing that, but I realized I have a tradition. So when I did the DOS assembly book, I had 10 chapters of really amazing programs, and I explained a lot of assembly language from the very beginner level. And then when I did my Linux assembly book, I did 20 chapters. I covered a lot more ground. I added more content, specifically on about the operating system, Linux operating system, how to get things done, and even how to use a PC emulator to run Tiny Core Linux. Like, I went really far out with the Linux edition. It's probably my best book I've ever published, although the chess book could also compete with that role. Anyway, so I was thinking, if I'm going to make a Windows edition of assembly arithmetic algorithms, I really need to take a different approach. I want to take a very simplified approach, and what I was thinking about is, what benefit can Windows users receive by learning assembly language? And I thought of something, okay? And this is why I'm recording a video. The reason I'm recording a video right now about this is because I had an epiphany. I thought about this and I realized that, so Windows is the only proprietary operating system that I still use at all, because it's installed on computers you buy. Aside from that, I use Linux and open source for everything. But I was thinking about Windows. What is it about Windows? Does Windows offer any benefit that Linux does not? And here's what I realized. I realized that while I may not really be a Windows user anymore, because I've been using Linux for like 25 years at this point, I do realize that assembly language becomes more important when you are reverse engineering games and other computer software that's proprietary. Because Windows is proprietary, then in order to modify games, people who, hack ROMs and modify Windows games to change the behavior of games and mod them, mod the graphics, mod the stats of characters, learning assembly language is a great help. Because I remember very specifically, when I was hacking Cave Story on Windows years ago, I was using Cheat Engine to hack the Windows version of a Cave Story. And because I had already known assembly language, like I actually knew assembly language back when I was a teenager, though I never really did very much with it. Now, what I did is, I used Cheat Engine to find out what writes to an address of the hit points, for example. And then what I did was, I found the exact assembly instructions, and I found what the exact opcodes were, the exact sequence of hex bytes, where they were that did that code. And you know how, and so I copy paste that to a separate text file. And then it has an option to replace it with no operation, where it replaces with 90 and hex. So it nullifies the operation. There's actually an instruction that does nothing on Intel systems, which is actually pretty cool. But anyway, so then I figured, well, the other way to make sure the change is permanent is to modify the executable directly. And once you know the sequence of hex bytes, you need to open up the executable file, find that exact same sequence using your hex editor search feature, and then change those bytes to 90. And you can do that. You can do that on Windows, you can do that on Linux, you can do it on anything. But I specifically remember doing that in Cave Story. I remember doing it in Castle of the Winds. I even remember doing it for this one game. There's an esoteric game you've probably never heard of. It's called Mega Mari. And it's where you play as Marisa from the Toho video game series. But it's like a fan-made game where it's like Mega Man. It's like Mega Man 1 for NES, except you're playing as Marisa the Witch from the Toho games. It was the funniest game, I tell you. And that game was really hard. So what I did is I used my hex editing, cheat engine skills, my assembly language knowledge to make myself invincible in the game so I could finish the game, because the game was too hard for me to play normally. And that's just the kind of thing you do when you are a gamer and you use Windows, you know? And I was thinking about it, and I thought that, what if I take a whole different approach? For the Windows edition of Assembly Arithmetic Algorithms, if I write this book, I'm going to do a whole new thing. I'm going to briefly touch on both 32-bit and 64-bit Windows API calls and include a few basic programs. But I may include more than that. I may include things for the Windows edition that I did not include for the DOS or Linux edition, because Windows is different, because of the fact that Windows is a proprietary operating system, and reverse engineering games for which you don't have the source code is more of a thing. I may make the Windows edition more gaming, reverse engineering focused. That might be what I do for it. I'm not sure if that's the route I'll take, but there's another route I may also take. The other route I may also take is I may focus on the benefits in terms of speed and the benefits in terms of making smaller quality software that takes less space and executes faster than the same program written in C, or C++. And because it is called Assembly Arithmetic Algorithms, and because integer sequences are a very valuable part of what I do in assembly language, as well as all programming languages, I will still have to include, my chapter on the assembly language instructions that I'm using, obviously. I'll have to include that, but I'll also have to, include more information specific to integer sequences. Like I may really get into explaining, this program takes up so many bytes of space, only a few kilobytes, and yet it can produce a huge output. And I think I have ways of doing that. Like I think I have some pretty cool ways where I can do that, and how you can use assembly language to write super small programs that generate a lot of data. And that might be the route I go. And so these are just some brainstorming moments I have, and I just really wanted to record a video to get my thoughts out to help remind myself when I'm writing the Windows edition of my assembly book. So thanks for listening to my walk and ramble. Anybody who enjoys this, I am such a nerd, I swear.